Good day, I'm Maile Madziba. Welcome back to our channel. We're continuing with our 2017 study guide of CRR 113. We're looking at example 5.1.2. It says 500 kilograms of a solution saturated with NaHCO3 at 60 degrees is cooled to 10 degrees Celsius. Now the question is, what is the crystal yield in kilograms? It goes further to say that the solubility data is as follows, and it shows the table there. There's an illustration and a diagram here. What's basically happening is that there's 500 kilograms of a saturated solution of NaHCO3 in water, and this solution is actually gets to be cooled to 10 degrees Celsius, and in cooling this, there be NaHCO3 crystals. Let me just write crystals. So it was 500 kilograms of a saturated NaHCO3 at 60 degrees, and after cooling to 10 degrees Celsius, it now turned to be a saturated solution of NaHCO3 at 10 degrees, and as a result of the cooling from 60 to 10, there be NaHCO3 crystals that it formed. So the question says, what is the crystal yield? They want to know the amount of the crystals that is actually formed. So for us to actually be able to answer the question, we need to choose a basis as usual. So a logical or an easy base would be the 500 kilograms of the original solution. So we can say basis 500 kilograms NaHCO3 saturated solution at 60 degrees Celsius. So this is basically our basis, or this is our basis. Now when we have that, the second question that we need to ask ourselves is, how much of NaHCO3 is in this 500 kilograms, and also how much of the water is in there, because this is actually what's going to help us to know what happened here. So now this takes us to our step one. I can just say step one. For us to be able to calculate how much of NaHCO3 left, rather how much of NaHCO3 and water is in here, we need to know the mass fractions of both NaHCO3 and the water. And using those mass fractions, like we've always done before in our first section, we can multiply those mass fractions with the 500 kilograms and get the mass of each of NaHCO3 and HO2. So our step one would be calculate the mass fractions of NaHCO3 and water in the 500 kilograms NaHCO3 saturated solution at 60 degrees Celsius. So we need to calculate the mass fractions, and the advantage we have here in calculating the mass fractions is that we have the information here. We are told that this actually grams per 100 grams of H2O, so which means at 60 degrees Celsius, there's 16.4 grams of NaHCO3 for every 100 grams of H2O. So for us to get the mass fraction, we would simply say mass fraction, let me just mention that, of NaHCO3, let me just write here that at 60 degrees Celsius, mass fraction of NaHCO3, 60 degrees saturated solution, 60 degrees, at 60 degrees saturated solution, the mass fraction of NaHCO3 equals to, it's going to be the 16.4 grams all over both 16.4 grams plus 100 grams. So it's 16.4 grams all over the total, which is 16.4 grams all over 116.4 grams equals to. So now this falls off, and if you use a calculator, it will give you 0.14089 That is basically the mass fraction NaHCO3 at 60 degrees Celsius. That is actually the mass fraction. Now we need to calculate the mass fraction of water still at 60 degrees, and yeah, let's just write here that mass fraction H2O equals to, remember they say it's 16.4 grams for every 100 grams H2O, so which means the H2O is 100 grams, so we're going to be saying 100 grams all over 116.4 grams. Now if you use a calculator, it will give you 0.85911. So if you use a calculator, it gives you 0.85911, and the grams fall off. This is actually the mass fraction of water. So we have both the mass fraction of the NaHCO3 and also the mass fraction of water, H2O. So now with that said, we are done with our first step. This takes us to now to our second step, our step 2. So we can say step 2, remember now that we calculated the mass fractions, we can easily calculate the amount of each NaHCO3 and H2O in the water, because we have the mass fraction and also the total solution. So with that said, our step 2, we say calculate the amounts of NaHCO3 and H2O in the saturated NaHCO3 solution at 60 degrees Celsius. So this is actually our step 2. Now with that said, we know very well that, let me just write that, at 60 degrees Celsius, saturated solution, yeah, let me just put a line to it. Yeah. We know that NaHCO3 equals to mass fraction of NaHCO3 multiplied by the total mass. Now this gives us, we already calculated that the mass fraction of NaHCO3, we calculated it to be here to be 0.140893. So it's 0.140893 multiplied by our total mass. Yeah, our total mass, we know that it's 500 kilograms, so it's multiplied by 500 kilograms. Now if you use a calculator, it gives you, let me just verify here, it gives you 70.4465 kilograms of NaHCO3. Now we go further to calculate for the H2O. We also know that it's actually mass fraction H2O multiplied by total mass. So the mass fraction of H2O, here we have it, here we calculated it. So we know is 0.85911 multiplied by 500 kilograms. Now this gives us, if you use a calculator, it gives us 429.555 kilograms H2O. Now this tells us that inside the 500 kilograms of the NaHCO3 saturated solution at 60 degrees, there's actually 70.4465 kilograms of NaHCO3 and 429.555 kilograms H2O. So that is basically an important analysis we have now that we have much more clearer information with regard to that. Now this takes us to our step 3. Step 3. Now remember that now that we calculated here, we want to know how much crystals formed, but we don't have much information about the crystals, but we have the information about part of information on the saturated solution at 10 degrees. We have the data here that actually tells us about what happens, or rather what happens to, I don't know, how do I put it, the composition of the saturated solution of NaHCO3 per 100 kilograms of H2O. So we have the data here. We can actually use this ratio like we did here and calculate the mass fraction here then. See? So that takes us to our step 3. So step 3, we calculate the mass fraction of NaHCO3 and H2O at 10 degrees Celsius saturated solution. So that is actually our step 3. So but now when we look at the data, we can easily get that. We can just say mass fraction NaHCO3 equals to, it's actually, where is it? It's 8.15 grams per 100 grams. So it's gonna be 8.15 grams all over 100 grams plus 8.15 grams. This gives us 8.15 grams all over 108.15 grams. So now the final answer becomes, when you use a calculator, the final answer becomes 0.075 358. So that is actually the mass fraction of NaHCO3 at 10 degrees Celsius. This is actually the mass fraction of NaHCO3 here. Now we do the same with the water, and we can just say mass fraction H2O equals to 100 grams all over 100 grams plus 8.15 grams. This gives us 100 grams all over 108.15 grams. Now if you use a calculator, that would give you 0.924642. So that then is actually the mass fractions of both the NaHCO3 and also the H2O at 10 degrees Celsius. So now that we are done with our step 3, which was calculating the mass fractions here, we now go to our step 4. You can see step 4. Now that we have the composition here, we need to calculate the amount of the total amount here. And yeah, we can actually name it X because we're actually going to be calculating it. And okay, let me just write down, let me just describe the step and say calculate the total amount of the NaHCO3 saturated solution at 10 degrees Celsius. Now that we have a composition, we know the composition, we rather know the mass fractions of both, and we tempted X. We need to calculate that, and it's going to be much easier if we look at an important principle like we did in our previous example, 5.1.1. We have a Thai compound here, which is water. Remember that there's all the water here, and there's all the water that is here comes here, because in the crystals there's no water. Why? Because it's crystals. So we have water as a Thai compound. We know the water here is actually the water there. And remember that we know the water here, and we've calculated it to be, let me just verify, we calculated the water to be 429.555. Remember, this is actually the water. So which means here is 429.555 of water, and also here is 429.55 water. So we can use the water, the knowledge of the mass of the water here, and use it here, and use the X and the mass fractions and make up an equation to calculate X. And we'll actually do just that. So yeah, let's go. Step 4, and so we say, let's just say water balance, water so it's a water balance. So let me just bring the structure. We know that water, let me just say mass H2O at 60 degrees Celsius saturated solution equals to excuse my handwriting, mass of H2O at 10 degrees saturated solution. This is basically water balance. We are basically saying all the water here equals to all the water here, and we know that water here, we calculated it to be 429.555 kilograms. This is actually the amount of water here equals to, we don't know how much water here, but we know the mass fraction of the water, and also we have defined this to be X. So we can actually multiply the mass fraction and the X, and we get that. And the mass fraction of water became, let me just verify, yeah, this is it. So it became 0.924642 by X, and therefore X equals to, let me just verify here. So when you calculate the X, it gives you 464.5636 kilograms. Now with this said, this means that the total solution here is actually 464.5636 kilograms. And if that be the case, then we can use the mass fraction of NaHCO3 to actually get the NaHCO3 here. And we'll do just that. And with that, it takes us to our step 5. Step 5, which is calculate the amount of NaHCO3 at 10 degrees saturated solution. And that is, and we can just say, therefore, NaHCO3 equals to this 464.5636 kilograms multiplied by the mass fraction of water, of rather the NaHCO3. Let me just bring it here. Let me just verify.